This is lesson 1.4, Properties of Numbers. In this lesson, I am going to show you several properties that allow us to more easily solve problems using mental math. So first, I'd like for you to try to simplify these two expressions without using a calculator. So using mental math, don't write down your work, try to do these in your head. If you had trouble doing that, one thing that might help you is to know that when an expression uses only multiplication or addition, you can actually manipulate or move the numbers around to make them easier to solve in your head. So for example, for this first one, you can actually do the problem in this order, which makes it a lot easier. 20 times 50, if you use a little trick of multiplying 2 times 5 is 10, and then so 20 times 50, we're going to add those two numbers on, that's 1,000. And then 1,000 times 14, that's a lot easier to do, it's 14,000. For the second example, if you notice there's parentheses here, so technically we're supposed to do 25 plus 17 first. While this is not exactly impossible to do in our head, it would be easier if we did the 17 plus 13 first, because 17 plus 13 is 30. And it's much easier to add on to a number that ends in a 0. So 25 plus 30 is 55. So our strategy for both of these is to multiply or add two numbers together that will end in a 0, because it's a lot easier to continue to solve the problem from there and add on or multiply on to these numbers than the original problem. The properties of numbers that we're going to discuss today allow us to do that. So let's first look at the commutative property. The commutative property allows us to change the order of the numbers in an addition or multiplication problem. The key here is that the expression must be all addition or all multiplication. It cannot be a combination of operations. So if you want to add that on there, cannot combine operations to help you remember. It has to be all addition or all multiplication. So if you look at the two examples I have here, A plus B is the same thing as adding B plus A, or with numbers 6 plus 7 is the same thing as adding 7 plus 6. The same thing works for multiplication. A times B is the same as B times A, and 4 times 9 is the same as 9 times 4. So we can switch the order around as long as the entire problem is all addition or all multiplication. If we had a combination of addition, multiplication, maybe even subtraction or division, you cannot move the numbers around. So that is the commutative property. The second example that we did was an example of using the associative property, and this is similar, but in this case, this allows us to change the grouping symbols, which are the parentheses, and again, it has to be addition or multiplication, and only addition or only multiplication. So again, no combination of operations, all addition, all multiplication, this works. So for the examples, we have A plus the quantity B plus C will give us the same answer as the quantity A plus B plus C. So if you look at the example over here with the numbers, just to make sure that's true, 3 plus the quantity 6 plus 1, so 6 plus 1 is 7, 3 plus 7 is 10. The same thing is true over here. If I do 3 plus 6 first is 9, 9 plus 1 is 10 also. Same is true for multiplication. A times the quantity B times C is the same as multiplying A times B, the quantity, and then times C. So we can try that just to be sure. 5 times, this would be 18, is the same thing as 45 times 2. They're both 90. That is the associative property. Again, just to reiterate, this does not work if there is a combination of operations, multiplication and addition combined. This is not true. So just to show you, 6 here, 6 plus 1 is 7, 3 times 7 is 21. Over here, 3 times 6 is 18, and 18 plus 1 is only 19. So these are not the same. Okay, and that's because there was both multiplication and addition. You cannot regroup or reorder if there are both addition and multiplication. It has to be all addition or all multiplication in order to do this. Okay, the last few properties are common sense, things you already know, but they're just things that you can use to benefit and help you solve problems in everyday math. So the first one is the additive identity, and that just says that adding 0 to any number gives you results in that same number. So for example, 5 plus 0 is still 5. The multiplicative identity is similar, but instead of adding 0, here we say that multiplying a number by 1 results in that same number. So for example, 3 times 1 equals 3. Okay, basically what I like to remember is these are the identity properties, and that means what do you add and what do you multiply to keep the number's identity the same. So add is 0, multiply, we multiply by 1 to keep the identity the same. And our last property is the multiplicative property of 0, and that just says that any number multiplied by 0 equals 0, which again, something you already know. Okay, what I'd like to do here is to give you a few minutes to try to answer each of these questions. So what property of those properties we just discussed is shown here? This first one, you can see that the grouping is changed, so that is the associative property of addition. In this second example, we multiplied 1 times 3c and we got the same result back, so that is the multiplicative identity. In this example, we added 0, d plus 0, and we still get d as our result. That is the additive identity. And for the last one, you can see the order of the numbers has changed. That is the commutative property. And this is commutative property of multiplication. Okay, a challenge for you. What property is shown here? If you said the commutative property of addition, you are correct. This one is a little bit tricky because with all of the parentheses, you might think it's the associative property because we group things with parentheses. However, if you notice, the grouping, what's in parentheses, has not changed. What has changed is the order of those groups. So that is the commutative property of addition. Okay, one final definition for today is a counterexample. Sometimes you'll be asked true or false questions, and if you are asked to explain why an answer is false, something you might be asked for is to give a counterexample. A counterexample is just an example that proves that your statement is false, and you only need one of them. So for example, the product of two odd numbers is always even. So if I say that's false, my counterexample would be 7 times 7 is 49. Obviously, 7 and 7 are both odd numbers, but the product is also odd. So that proves that this statement is false. It's not always, the key word there was always. So maybe it's sometimes true, but it's not always true. So we say it's false, and then we give a counterexample. Okay, here's an example for you to try. True or false? If false, give a counterexample. The statement says subtraction is commutative. What do you think? Is that true or false? That is false. Subtraction is not commutative because, and then an example you could give, a counterexample, is that 5 minus 4 is not the same thing as 4 minus 5. They are not equal, so you cannot reorder a subtraction problem the way that we can reorder an addition or multiplication problem. Okay, so that is lesson 1.4, properties of numbers. I just wanted to take a second to go over what topics will be on your quiz this week. So we have 1.1, 1.2, 1.3, and 1.4 are the lessons on your quiz. Here are the topics that we studied. If you have any questions about these topics, please let me know.